Okay, so we're going to start talking about function rules. A function rule is just an equation that represents an output value in terms of an input value. So that might be something as simple as y equals 3x plus 2. So it represents my output value y, that's what's isolated, and it has in terms of x my input value. So that's a simple function rule. It's just an equation, but it does mean where your output value is the one that's isolated and by itself. Function notation you're familiar with is f of x. So that's how we would read that, f of x. And it doesn't, we normally use f for function, but it could be something else. We can have g of x or h of x or a of x, just like we can have different variables in our equations. So that's read f of x equals 3x plus 2. So it's the same equation. This is just written as a function rule or as an equation, and this is written as function notation. But we know that x means that's my variable or my input. And then what I get out of this, f of x represents my whole, y, my output. So if I was making like an xy table, instead of an xy, I would have x and f of x, which is your y. So if I had f of 2, now note, 2 is replacing x, so my 2 should replace my x. And 3 times 2 is 6 plus 2 is 8. So my input is 2, my output is 8, or we can say that as if I plug in 2, I get 8. A lot of people will get confused on this and think that this means I'm multiplying f by 2. That would look like that. This says I'm plugging 2 into f, and I'm replacing whatever that says, which was my x. We've already talked about independent and dependent variables. Independent represents your input, that's your x, that's your domain. Dependent represents your output, that's your y, that's your range. So let's put a little bit of this into application. Tickets to a concert are available online for $35 each, plus a handling fee of $250. So that $250 is a one-time handling fee, like an online cost. The total cost is a function of the number of tickets bought. So what that means is different inputs, I have different outputs. So, if I buy one ticket, and then I buy 2, the cost is going to go up. If I buy 3, the cost is going to go up. Unless they're running a deal or something, I can't plug in multiple X's and pay the same amount. So I can't buy 3 tickets and pay $50, but then buy 6 and also pay 50, right? So for a function, you can't have your X's repeat. And so anytime we're talking about getting different amounts of something, that would be a function, unless it's just a rare case where you can buy a bunch in bulk for different prices. So it says what function rule, that's going to be our equation, solved for our output variable, models the cost of the concert tickets. So I'm going to use x and y. You could use, t for tickets or whatever, but y equals, I have 35 each, so per ticket, and then a $2.50 handling fee. So x is my tickets, y is my cost, and that would be great for us. Y would be the total cost. Okay, so I answered that part. Then it goes on to say evaluate the function for 4 tickets. So now I'm going to plug in 4. You can write that in function notation. And this would not be an acceptable answer. And I think you know why. We are talking about the cost of it. So first of all, it should look like an American money amount, and it is dollars. And so both of these would be your answer. That would be your final answer, and then this would have been your equation. So always make sure you read, make sure you answer all parts to it. I want you to pause this and work number 8 by yourself, and then start it back up and check. So now that you've paused it, you've worked it, and you're coming back to check it, I'm going to work it with you. You're buying bottles of a sports drink for a softball team. Each bottle costs $1.19. What is the function rule? Models the total cost of a purchase, and how much would you buy? How much would it be if you buy 15 bottles? So it is a straight, we're going to talk about this, direct function. There's no like additional cost that I have to add on. So that's my first answer. And then whether you write it in function notation or what, when I put in that, and of course we will write it as a dollar amount, because that is the units we're in. And those are our 2 answers. Lastly, I'm asking you, just kind of as a review, to give an example of a relation that is a function and a relation that isn't a function. You could write an equation, you could draw a picture, you could do a mapping, you could do points. So why don't you pause and give me examples of this and then check back with me. So I'm going to do my example of a mapping because that's easy for me to see. So if I have I'm just going to pick some numbers for my input and for my output, and I'm going to make this be a function. So like, yes, this is a function. I can have do something like that. So I have 1 and 3 both going to 5, but this is still a function because my x's don't repeat, right? If I want to write that out, my y's repeat, but that's okay. My x's don't repeat. I don't have the same x value going to more than one y. So this is still a function. If I want to do something similar, not a function, it might look something like this. Just something like this. So, sorry. I just need 1 coming from 2 places. That's actually coming from my 1. I just got a little sloppy there. And so I'm going to make this go there and even use my 3. It doesn't matter. This is the problem. From my 2, I have it going to 5 and going to 6. My x is repeated, so this is not a function. X repeated, going to different y values, not a function. X is not repeated, y's are. That's okay. So that wraps up lesson 1 on relations and functions. Now we're going to talk about a specific type of function, which is direct variation. And you've seen these before. These are linear equations that are just specific. So direct variation is a relationship where the ratio of corresponding values is constant. So what this means is that you might have an equation that looks something like y equals, I'm going to call it k for our constant variation, and x. This is what the formula is going to look like. We can find our k. And again, this is called the constant of variation. So it's our constant, it's our coefficient, but it's how much it's varying, and in this case, it's direct variation. We'll talk about indirect variation later. How you can find k, so this is just a number. How you can find k is you can solve k here, get y over x, and this would be for any point x comma y. So it says for each function, determine whether y varies directly with x, so we're looking for direct variation. If so, we want to find our constant variation, which is k, and write a rule. So remember, k can be y over x. So I'm going to take y over x, I did that one, and then y over x. And I want to see if all of these are the same. So 2 over 1 is 2, 6 over 3 is 2, 8 over 4 is 2. So all of these are the same. It does vary directly. So the first part is yes, it varies directly. My constant of variation, all 3 simplify to 2. Now it would only take one of those to break the rule. So if 2 of them simplified to 2 and 1 didn't, then that wouldn't be enough. That's my second part. And then I'm going to write the function rule, y equals k, which we just determined to be 2x. This is direct variation. If, say, instead it was like 2x plus 7, if we had something added on there, it would not be a function. It would not be direct variation. Sorry, it would still be a function. What has to happen with direct variation is it does have to go through the origin, and you might want to make note of that. It has to go directly through 0, 0, which means we can't have a plus b for our y-intercept here. So I want you to pause this, and I want you to work b, and then check back with me. So I worked this, I got 4 over 1, 8 over 2, both of those are 4, and then 11 over 3. Nope, that's not the same, so y does not vary directly with x. I want you to pause it, work C and D, and then come back and check your work. Okay, so checked all three of these. They reduced to -7. Yes, k is -7, and there's my function rule. On D, I just checked two of them. They didn't. Oh, sorry, that's three. They didn't line up, and so no, y does not vary directly with x. So now we're going to do this with equations. And so again, think about maybe like this one. As long as y equals some number times x, you are good. So if I take e, so I'm still doing the same thing. I'm seeing if these are still the same directions. I'm seeing if it's a function where y varies directly with x, and if so, find k in the function rule. So I'm going to solve for y. And there we go. There's my function rule. Yes, it works in that format. All right, y equals some number times x. So yes, it works. There's my rule. And my k is 7/3. Okay, and if we go over to f, some of you might can already see this, of course, but if I divide by 7, I get that. And nope, I got that +1. So it doesn't work because that's not direct variation, right? It has to go to the origin. It has to be y equals some number times x. So no, and this is where you go on to say y does not vary directly with x. I want you to pause it and work G and H and then check back. So both G and H worked. Remember, you're answering three things here. Yes, it worked, my function rule, and my k. Yes, it worked, my function rule, which was actually already given to me in my k. Notice a lot of these have fractions that are k's. Some are negative, some are fractions bigger than 1, some are fractions smaller than 1. It doesn't matter. As long as it is y equals some number times x, I can multiply the same thing by x every time, not add anything to it, then it is direct variation. So suppose y varies directly with x and y equals 9 when x equals -15. What is y when x is 21? So you can write this as a function rule, or you can set up a proportion. So I have, remember your is y over x. I know my y is 9 and my x is -15. So there's my k. And I want to know what is y when x is 21. So I can write my function and then I can plug in x equals 20. This would not be your final function rule. This is fine for calculation. But if it didn't ask you to write a function rule, but if it did, you of course would want to use a reduced fraction. And get that. That's my answer. You can also set it up as a proportion if you prefer, like 9 over -15. Remember that was my y over x, so then I would put y over, and my x is 21. And if you work it that way, you're going to get the same thing. So pause it, work number 3, and then check back with me. Okay, so use this to fix any mistakes you might have had, and then we're going to go on to number 4. A salesperson commission varies directly with sales. For 1,000 in sales, his commission is 85. What is the commission for 2,300 in sales? So same thing. You can set this up as a proportion, which for some of you is the easiest way. And remember, as long as you're consistent with it, it doesn't matter how. Or you can say, hey, we have 85 in commission for 1,000 in sales. That's my And so you can use that as a fraction or as a decimal, and you can write your equation and you plug in. So probably the proportion is better, and this way it's just more in line with what we have to do for the function rules, and either of that is totally fine. So I want you to work number 5 and then check back. Okay, so I got 280 calories. We do want to make sure we include those units. Now I want you to do number 6. There's just 4 things you're graphing. These are all direct variation. They have nothing added. So they'll go through the origin and then you'll use your slope. So do that as a review and check back. So I graph through the origin. Like here I use my rise over run. Started the origin, rise 3, run 4. Remember, you only have to have 2 points to make a line. I use 3. Make sure you use arrows. I would expect you to use a straight edge. I couldn't because I'm on my screen. So you can use these to check. Again, at least 2 points. Remember, negative should go this way, positive should go up, but all of these direct variations should go through the origin, and you can use your slope. Great job.